So my name is Sir Richard Roberts. I'm the 1993 Nobel laureate in physiology or medicine for the discovery of introns and exons in eukaryotic DNA. The meeting is called Serendipity in Science, and the idea behind the meeting, and particularly the idea behind my talk, is to explain how very often the big discoveries in science are not planned from the top, but they hit us just by accident. And the main purpose is to show that while one is doing research, you always come across results that you didn't expect. Sometimes these results come because you didn't set up the experiment properly, sometimes because you didn't perform the experiment properly, but every so often it's because nature is trying to tell you something that we didn't already know. And this was my case. We were studying promoters, that is the sequences that precede a gene that tell the organism where RNA transcription should begin. And we were trying to characterize one of these in a small human virus called adenovirus. And we were hoping to find out whether the sequences in DNA involved in this were the same as those in bacteria. During the course of doing this work, we came across some very unexpected findings that just didn't make sense on the basis of what we knew about transcription and gene structure in bacteria. Fortunately, I was working in a laboratory where it was okay to change the focus of my research so that we could follow up on this extraordinary observation. The bottom line was that after about 9 months of work, we came across the main reason, the real reason why we were seeing these unexpected results, and it was the fact that whereas in bacteria, genes are just a continuous segment of DNA, in eukaryotes, they're actually split up into pieces. The pieces that code for a protein are called exons, and the pieces that are in between are called introns. This was an incredibly important discovery because prior to that, everybody had assumed that the genes in bacteria and the way in which they were transcribed and made into RNA and ultimately coded for protein were absolutely identical between humans, between viruses, between bacteria, in fact throughout life. And this was the first time that that overall global hypothesis was challenged. It was a great discovery to make because no one had predicted it, and so that made it all the nicer to make. And it was a very serendipitous discovery because we had absolutely no idea ahead of time that it was going to happen. And when I look back on my life in science, I find that there have been many times when the work that I've been doing has led to these kinds of serendipitous discoveries, things that we weren't looking for, but that in fact turned out to be quite interesting. Now, lots of times things are not huge discoveries, many times they're just small discoveries, but nevertheless, this is how science proceeds, this is the way that science must proceed, and it is absolutely essential that scientists have the freedom in order to follow these unusual observations whenever they look as though they're going to be important. I hope you'll come to the conference. I think it's going to be a very, very interesting one, and one that's never been done before. Okay, thank you.